Special cases for motion in one dimension. Case 1 for average speed. If a particle travels distances x1, x2, x3 with speeds v1, v2, v3 in some direction, then total distance traveled will be given by x1 plus x2 plus x3 and so on. Total time taken will be x1 upon v1 plus x2 upon v2 plus x3 upon v3 and so on. Hence, by definition of average speed is nothing but total distance upon total time, that will be x1 plus x2 plus x3 and so on upon x1 upon v1 plus x2 upon v2 plus x3 upon v3 and so on. Now, based on that, if you have a certain case where x1 equals to x2 equals to x and x3 and x4, the rest of the values are 0. Hence, in that case, average velocity will be x plus x upon v1 plus x upon v2. Hence, simplifying it, you get average velocity will be 2v1 v2 upon v1 plus v2. We will solve an example where such a concept can be directly applied. A body covers one half of its journey at 40 meter per second and next half at 50 meter per second. Find its average velocity. So here when they mention one half of its journey and next half, that means the journey is divided into two equal parts. So x1 will be equals to x2, that will be equals to x. Hence we can use the above expression. Here the values are given. So V average will be 2v1 v2 upon v1 plus v2. Therefore, substituting the values and simplifying it, you will get the answer as 44.4 meter per second. Now, case 2 for average speed. If a particle travels with speeds v1, v2, v3 and so on in time intervals t1, t2, t3 and so on respectively in some direction, then total distance traveled will be v1 t1 plus v2 t2 and so on up till vn tn. Total time taken will be t1 plus t2 plus t3 and so on. Hence, average speed by definition, total distance upon total time, that will be v1 t1 plus v2 t2 plus v3 t3 and so on upon t1 plus t2 plus t3 and so on. Now, for this case, if we have equal time intervals, that is t1 equals to t2 equals to t3 up till all the n values are equal, let us denote it by t, then the above expression can be simplified as V average will be v1 plus v2 up till vn upon n. All the t factors in the numerator and denominator will get cancelled, which simply means that the average speed during equal time intervals will be nothing but the numerical average of the given values. You don't need to solve an example for that right now. Next case is for displacement in nth second in uniform accelerated motion. To understand the concept of displacement in nth second, let us consider motion of a particle along this line from left to right. The different position of the particle starting from 0 to the nth second will be something like this. Hence, this position indicates the displacement up till n minus 1 seconds. Now, to find the displacement in nth second, it simply means that the displacement from this position till this position, that will be the displacement in nth second. So, for that, we can use second equation of motion. First, Sn, not nth, Sn will be given by un plus 1 half an square. Sn minus 1, that is the displacement up till n minus 1 will be un minus 1 plus half a n minus 1 the whole square. To find the displacement in n second, we simply take the difference between Sn and Sn minus 1. That will be Snth equals to Sn minus 1. Substituting the values and simplifying, we get un minus u into n minus 1 separated plus half a, that is constant, it stays outside the bracket, into bracket n square minus n minus 1 the whole square. So this we will further simplify as un minus multiplication will give us un, that will be 0, and this minus n minus will give you plus u. So that is what remains, plus half a into bracket n square minus, this is n minus 1 the whole square, that will be expanded as n square minus 2n plus 1. Further simplification gives u plus half a as it is in the bracket n square multiplying the minus sign minus n square plus 2n minus 1. So n square minus n square is 0. So your final equation for displacement in nth second will be u plus half a into 2n minus 1. Now this expression can be used anytime you have to find the displacement in the nth second. Let us solve an example to understand the concept completely. A ball falls freely from rest. Find the ratio of the distances travelled in first, second, third and fourth second. Now as implied, nth will be u plus half a into 2n minus 1. Here it starts from rest, hence nth will be simply half a into 2n minus 1. S for the first one will be half into g into 2n minus 1. Since it is freely falling, we will take acceleration as g. That will be g by 2. Second, s second will be half g into 2 minus 1. That will be 3g by 2. Similarly, s third will be 5g by 2 and s fourth will be 7g by 2. As it is clear that the common term here is g by 2, hence the ratio will be 1:3:5:7. Now, for such a question to be asked in the form of multiple choice question, then these ratios can be given in the options, or if the same question is asked in theory exam, then the question can be reformatted as prove that the ratio of distances travelled by a freely falling body is the ratio of odd numbers. Now instead of freely falling bodies, they can also mention a body performing uniform accelerated motion starting from rest. So you have to understand the question and apply the concept respectively. Now as I always say, practice, 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 and you have to practice the numericals and more questions so that the concept of the chapter can be understood completely.